So I came across this question in Stack Overflow, which is drawing graphs with colored nodes. And basically this person has constructed this code to draw a graph. And what happens is, what he's saying is, I wrote some short code that works. Apparently it works. See below, but the uncolored and colored graphs don't have the same layout. So I copy all of this code, and I've already done this copying bit here. And I could zoom in a bit. Control. Let's just zoom in a bit on this. But basically, this is the code just in short, so you can see it a bit and possibly a bit clearer. I'll zoom back out for the purpose of copying. But this is all the code, and I'm going to, and this was the actual question there. I wrote short code that works below, and the uncolored and uncolored graphs don't have the same layout. So let me just control minus it a couple of times, get back to the 100%. So I did copy all of this code here, copy that, and I went and stuck it in, and actually I've done a follow-up underneath, so I'll show all of them. But what he's actually referring to was this bit here. So I'll copy and paste it back in, Control V like that, and then go to run the code. And when I run it, the first thing is that I got this error message. So you're seeing an output of how I fixed it. VS Code, or at least a Python, the Python error checker, points exactly with the arrow. It says gdraw there, and it says module NetworkX has no attribute. And the first thing I do is I go to, or I try to replicate the code. So I do nx dot from, with a dot from numpy, and we see here we got from numpy matrix, right? From. So this from numpy array and from numpy matrix, and he's used this from numpy matrix here, and then adjust adj, right? And that kind of like that didn't work. And again, like, it's not even the case that, so I can take his gdraw as well and copy that and paste it over there, hit equals, and sort of like remove this line. But we can see that these lines are the same anyway. So when we run it, we get this error message. And I did notice, I don't know why, but when I started to reconstruct it, the from underscore numpy, we get these two things. I go, oh, you know what, I'll try this one. So from numpy array, and then I run it, and we get the replication of what this guy means, which is he's got these grey ones, and node 4's up the top, 3's over there, 2's over there, 1's over there, 0, and so forth. But it's completely different in the orientation. But what's even more annoying is if I run it a second and third time, they just get these random orientations. And I know that it's random in the code here. But where does this random get used? Let's have a look. Control F. Let's find the randoms here. There we go. Randoms used here in the color.samples, but that's not going to do any more than change the range, like the coloring range. So I could actually even eliminate that and just do something like, because it's got 0, 1, 2, 3, and 4, we could do something like, let's just say, I'm going to say also this is bad practice, right? We don't use capitalized. Capitalized things are used for classes normally, so it's not the best written code. But anyway, we'll take this color, paste it here, and then equals to, let's just say 10, 20, 30, 40. I think this should suffice because there's only 1, 2, 3, 4, 5 things. So let's just comment that one out. So we don't even have the random now actually anymore, so we can comment this one out. Let's just get rid of the random over here. So we don't have the random anymore, and we can attempt to run the code and hopefully it works. Yes, it does. And maybe I'll create a larger color disparity. I think the highest is 255, so let's make it a 200, say for example, 150. 100, 75, and 25. There we go. And just run that piece of code just for our coloring anyway together. But anyway, we still notice that, so it's not even like this random that you might have thought maybe that's changing each time the code's run. So it's not even this. So every time we run it, we still get like these different arrays. So I thought what I'll do is I'll go and look at NetworkX and see what we can get. And a quick way of doing that was go to I'll copy this in here, and I actually did have this open somewhere anyway, which is over here. Yeah, if I just do search Google for NetworkX, and I did have a look at this before. Was it here? And then I went to the home page. By the way, already over here, it gives you sort of like some examples and usages of it. So the first thing that I proposed was maybe, did I use that as an example? I'm not sure. So I posted my answer, and but I actually show you where I took the answer from, which was if I go to this home page, and I used a modified version of this, so maybe I will actually have to. But basically, you've got a whole bunch of galleries here of things that you can do, and I've got to pick the simple graph one because it kind of like looked closest to what this guy was doing. And this is the NetworkX gallery, and it's 4 graphs effectively. So like, you can read and write graphs and so forth. But here's a simple graph with a minimal layout. So in the VS Code here, I posted my solution, although he's very ungrateful for it, or apparently he found his own solution. Didn't get an upvote. It'd be nice. I might put this Stack Overflow question in the comments, and someone else can upvote it if you like it. He's used the pos parameter. That's another way of doing it, by the way. It's sort of like there's loads of arguments that you can put in there, and you can sort of like force things to happen. But I took this modified version. I wonder if I actually even did the color things of it. Oh yeah, I did. I'll go back to it, but I took this standard graph documentation because it gives you this thing, but the nodes were a little bit fatter. And there was a directed graph as well. The directed graph has got arrows pointing, so it's got some sort of directional thing, whereas this one here is just the nodes and the edges. And you can go and copy all of this code like that, and we can go and stick this code. I'll copy it right over his code. There we go, and we can actually run it, I think, straight away. But you get these big fat edges, so I thought, you know what, font size, well, let's just make that 6 to have a small font. Node size, let's make that, I guess, 300. Is that still big? You can see the line width. We don't want these big fat lines anymore, and then width as well, 5. So we'll probably pick fat nodes, no, thin nodes, because line width of the node and width must be the width of the line. So there we go, something like that. And that automatically packs everything. And then if I was to go back to the code, I'll move all of this out of the way, or I'll Control plus it, so we get a bit bigger there. We can see the writing a bit clearer. If I wanted to put an array in there so that everything was different colors, I actually did it down below somewhere as well, but yeah, you can do well, you got this edge color argument that seems to be available. I wonder if the edge color argument was in here. Yeah, it's got edge colors black, but you could set, so we'll just do colors equals, and then I guess I wonder if you could actually do like different colors, for example, like a matrix of black. I don't know if this is possible. Orange, yellow, red, and green. Let's have a little attempt at that. That's got 5 because there's 1, 2, 3, 4, 5 nodes. So, and then we would need to have colors. This may or may not work. Colors, and then run it. It does. Although I managed to change the edge colors. Well, I presume maybe was it the node color or the line colors? Because I put edge colors, but it's actually changed what I'm going to call the nodes, which is interesting. So I guess maybe if I do node colors, that would change that. But that's inside the nodes. What was on here that changed the edge underscore color? Okay. So possibly another argument here. Those in options. I wonder. It might fail. No, it does work actually. So you've got edge colors. Edge colors refers to the node edges, and then so we'll turn these back to black, and then edge underscore colors. And this is kind of like the way that you can do it. Also, like I had a little play around because it was there. You could do like widths, like a list of widths, for example, and you could sort of like make them get bigger and bigger and bigger. So 1, 2, 3, 4. I don't even know if this will work, if the array is the right length or not. But I'm going to change it to width like that and see if it works. And yeah, it does. So we get these fatter going widths as you go along. And one of the things that I think you can do with the colors is something like, and I did have a play around with it in another one, and I'll still like show you, but here I did like color equals I times len over that, but I'm actually wondering if you could actually pick the RGB colors. Well, not imagining, I'm quite sure that you can pick the RGB colors and then sort of like have a going from like a light red to a very dark red, the further you moved around the nodes. So, but the thing about this is if we were to take this whole code, so we had these, this is the like, this is the one that's got colors in it, and then you know, I guess I could take this whole lot here. This was the non-colored version over here, which is no edge colors. So remove that, and widths are back to, let's just make them the same width. So 1, and I believe that when we run it, but noticeably it's the same orientation, it hasn't jiggled it around anymore. So this is kind of like, but anyway, I move on from that because we can go and take a look at that entire library, which is, let's just go back. You've got all of these things in this NetworkX library in Python. So, you know, compute some network properties for the lollipop graph, you know, some vertex and so forth, and it gives you I guess this is a source. Okay, so that's the source, that's the values that will probably go in. Average shortest path length. Okay, interesting. But anyway, here's the code that does it. I'm just wondering where it gets all of this. Okay, NX lollipop graph. It looks like it's a pre-created graph. 4,6. Is that what it actually creates? It might be. But I mean, arguably, you can create your own graphs or your own set of data. So this is providing examples of what one can do. Read and write graphs. So read and write graphs. There we go. Out in. I'm just wondering. That's a 5x5 graph, 5x5. But where's the data actually coming from? Is the question. 4-line, inline. That's writing it. I'm just wondering how you might read it, or change the values of it. Don't want to do that one. Back. I've done one of these myself in a different project. I haven't put that one on into a tutorial, but I still like had to play around with it because I wanted to get the heat maps, and that was what I was alluding to, the colors of the lines actually, which is that usually I want to get them darker and darker, or like you want to make them color coordinated. So finally, just on this, which is on the NetworkX, on its simple graph. Was it the simple graph that I used? No. wonder which one I did actually. I used the traveling salesman one, I believe. So I think it was this one because it looked also quite similar to the original question in a way. And you can sort of like play around with this quite a bit, but that was the actual code for it. And again, I go back to VS Code, um, which is this second block of code down here. And I'll just delete the entire first block of code because it already exists anyway. It's nice running it in the interactive browser with this hash %% because then we get like the code statically at the side. So this was literally a copy and paste of pretty much a copy and paste of the traveling salesman, but I did modify it because I wanted to put the coloration in here. So we've got this graph equals, and this is, I don't know, a better way of doing it basically, but graph equals nx.random geometric graph. I think I did play with the radiuses and the seeds. You can do different seeds and radiuses. And then the position, get node attributes of pos. But anyway, continue down. Depot should be this. But basically, well, here is the code that I played with because, and I'll actually show it. I think I got both of them here. So here's the plot.show. This is the one where I wanted to put some colors in. So let's add some color. The English version of color has a U and the American version has just a COLOR. So you've got to be careful about that. If you're English, I made that error. It could be a typo, so if I would have put in color over here, I get the squiggly warning, fortunately, which would return, I can't undo that. If I right click on it, or not right click, if I hover over it, it says color is not defined. So it helpfully avoids the error messages. But this color here, and this one here was the original piece of code. I can't remember even if I put in red on that one or not from the original piece of code. Or did they give red? They gave red. Red was over there already. So I possibly just maybe at most played around with the sizes a bit. But over on that, if I was to run this piece of code, we'd get something like this. And this is where I sort of like played around with it because you've got these red edges and then you've got these other nodes that are available. So I was like, okay, now I want to put some colorization in here. So here's my attempt at putting a colorization in. But then I actually wanted to identify, I thought, well, that'd be quite useful to identify which is sort of like the first node and make it darker and darker as you go from each node in the list. And I think somewhere above it starts at 0 and then goes to 14. So here's 0 and then it goes to 14 and then it goes to 16. So 0, 14, 16, and we can see then it goes to 10, 12, 15, and we can see it getting thinner and thinner. So I don't know if you could call this the most relevant node, but the starting node I gave it the thickest width. With this line width diminishing in size as we go on. And this is just the list comprehension. So I could actually print out width. So I could do just print over there. I would have to, print Python. Just do that. And then the width like that. If I just rerun it, you'll see the widths, and so that goes from, so it's just a list here basically, 20, 19, 18, 17, 16, getting smaller and smaller until you get to number 1. And how did this is generic, but what I saw is we've got pos here, which is created up here, but actually it comes from here, so len pos is the length of this of this entire array basically. So the length of the array, you're just basically iterating through, making it smaller and smaller by 1 increment each time. That's all it is, pos minus I for I in range. So as I gets bigger, we're just subtracting it from the original position. And that's basically it. So there's a whole bunch of these things as I said already, so we can sort of like see this. And if I go back, they're in the gallery section, a whole bunch of stuff that's interesting to use. This came about because the user had something that just seemed to move every time we ran the code, which I actually find very odd, and I couldn't debug for that or find the reason why. But you can certainly fix it, and there's certainly a whole bunch of node edge and node type graphs that you can do that are quite sophisticated actually, and there's more down the on the side. You even got, I guess, some 3D drawing versions of it. So something like this, a circular tree, might be quite useful. Giant components. So there's a whole bunch of things depending on the need that you want to have. So that's really it. That's kind of like NetworkX in Python. It's really a very top view of what you've got introduction, because each one of these will be quite intricate in themselves in how you implement it. So that's basically it. If you like the video, hit like. If you've got any comments or any improvements, by all means suggest or add them into there. And yeah, and also if you want to follow, that'd be very helpful too. Comments and follows are quite useful. Thank you.